Before I dive into the Azure Service Bus and its high availability features, let me first explain to you the concept of asynchronous messaging in application architectures, because chances are we've got a lot of people watching this that are infrastructure focused, they're not developers, so let's draw this out real quick. So let me show you a traditional kind of workflow here with the web application. So you might have a web server running on a virtual machine. Maybe it's an IIS server with an ASP.NET application. So the user visits that web application. They interact with the application. Maybe they submit a form, and then that web server stores some data on another system, maybe a database server, a SQL database server running another virtual machine somewhere else. And the data gets submitted into the database, and we can read it out later in the application. So that's a pretty standard model that most of us are familiar with. But the challenge here is that with this overall application, the database server could go down, the user could still get to the front-end web server, but when the user visits the application, if the database is down, the web application is just going to spit out a bunch of errors. So this is what we refer to as a tightly coupled architecture, and the concept of asynchronous messaging helps us out with this type of workflow. And so this is where the concept of queuing comes into play. So at this point, the architecture of the application has been modified. User can still visit the web server, the web application, but instead of the web server submitting data to a database, it actually drops a message in something called a service bus queue in this example. And so we could submit a bunch of messages into that queue from one or more web servers, and each of those individual messages can represent a record or a transaction that needs to take place in the backend service in the database. And the idea is that basically these messages are going to stack up in the queue, and you're going to have some kind of backend service, might be an Azure function, or it could be another virtual machine running a service that consistently just queries the queue and basically looks for messages that need to be processed. And if it finds one, it can take that information, then head over to the database server and submit that information. So the cool thing with this architecture is if the database server goes offline, the user can still interact with the web server can still store the messages in the service bus queue, and the queue listeners can basically just do a check and make sure that the database server is online. If it's not, it'll just try again later and submit the data later after the database implementation has been fixed. So keep in mind, this is just one basic example of where you might use asynchronous messaging within an application architecture. But if you look at the middle tier here, the service bus queue, we want to make sure that this thing is highly available, especially if we're talking about failing over to another region. Because if we've got data in the service bus queue and suddenly the region that we're working in goes down and we have to fail over automatically to another region, we want to be able to recover those messages in that alternate region. So Azure Service Bus actually has a couple of different controls that'll help us for high availability. So when you're creating what they call a namespace, which is kind of your core construct here in the service bus, you'll notice that while you're in the portal, if you pick a premium pricing tier for Service Bus, you can make this namespace zone redundant, which is great for single region deployments because you'll have multiple zones within the region where you can make sure your data is being persisted. And once that resource is built, you can go into the properties of that service bus resource in the portal, and then you can actually set up what they call pairing. So you can geo-replicate the content in that service bus namespace to an alternate or secondary namespace in another region. And just like we've seen in other examples throughout this course, when you fail over to that other region, the application architecture, the resources, the servers in that other region will be able to interact with the service bus in that other region as well. And all the data that was in the primary namespace has been replicated over to the secondary namespace. And that's really the idea for the high availability piece here for Azure Service Bus. So keep these things in mind as you go out and design your highly available architectures. And that actually brings us to the end of this module. Let's hop over to the module summary. We'll do a quick recap.